Alright, ready? Please come on. Okay. Hi, my name is Zhi Lin. I'm a part of the Clear Falls Independent Study Mentorship Program. My teacher is Ms. Holk, and my mentor is Mr. Brian.piercy. Most of this information is going to be used from outside sources, and it will be cited accordingly. So, ISM is like a website-based class. All of our work is documented on a website. So, for my website, on the first page, I have a slideshow of pictures, which I'll try to zoom in a little bit. Solenoid, and one of them acts as a fast-acting valve. You always want to test valve for each actuator because you always want the valves to be moving up and down. You don't want it to be stuck in a position for a long time. So the test valve, every designated amount of time it moves the piston up and down very slowly, which you'll see later on in this project. And the fast-acting valve is actually for real-world purposes, like when the whole system trips. So we're going to move on to the actual demonstration of the skid. You might have to move that.
This big can over here is going to be your emergency spill kit, not for normal cleanups, but if there's a large oil spill.
Do we have a muster point?
The
parking
skid is
lot.
supplied by this tank right here. It's supplied by oil. And there's two actuators according to my diagram. This is the governor valve, and this is the stop valve, or the trip or stop valve. And you see that they're both hooked up with LVDTs right here. And there's these two are solenoid valves, and these two, this is a servo valve, and this is a solenoid valve. Yes. And this whole manifold right here is hooked up to the stop valve, and this whole manifold is hooked up to the governor valve. I'm probably missing something. No, I think that's it. Okay. Then you might want to start.
Oh, you mentioned a test solenoid.
Yes.
Which one would be that function?
For the stop valve,
Yes.
it would be this top one,
Okay.
and
then
the bottom
fast-
would be the fast acting.
Okay.
So, if you trip, well, supposedly if you trip, well, the test solenoid, it actually closes slower according to what Mr. Hanson told me. It closes slower because there's like an orifice which channels the oil even slower. No, not slower, at a slower pace. So. And during this demonstration, I'll be showing what happens when I change a value. If I change like a Boolean value from like true to false or false to true, and see what happens with the servo controllers and the valves. So,
Okay. Are we ready for power?
yes.
Okay.
I'm going to demonstrate start on real quick.
I'm going to turn the skid on.
Yes.
What points are we trending? Are we watching on the trends? What are we looking at more than one point?
Right now I'm going to do So if you look at this diagram real quick, it shows a value.
Are those the solenoids
Which one?
that you're setting to true?
Oh yes, because I'm going to set them all to close and then do start.
Okay.
So we went through a scenario alternative startup where you would have a valve closed.
Okay, so stop valve is actually in a closed position, so I'm going to demonstrate startup for you. To actually open the stop valve, you're going to need to energize both the servo valves. Because if only one's energized, it's not going to open because it's fault tolerant. So here I am opening both of them. See, it doesn't both of them are energized and the stop valve opens. Okay. So I set the value to true. So once I increase the demand, like the valve should open. So here's the valve at 10%. And I'm just going to increase it gradually. You notice how it moves. Here's 20%. Here's 50%.
Your fast acting valve should actually be de-energized.
Oh yeah.
Like over here.
Is it open now?
Yes.
Okay. Yeah.
50.
Alright, 50. And then 100 on the demand. Okay. So if you look at the graph, the LVDT readings show that it's at a so now for shut down. Okay. So usually in startup you open the stop valve first and then you open the governor valve. So shut down, I'm assuming you shut down the governor valve and then the stop valve.
For controlled shutdown, that's correct.
So I'll set the demand to 0.
And normally that would also be stepped down slowly, but that's okay.
Oh, okay. And then set the solenoid to true. So now it's fully closed. And then for the stop valve now, if you set one of them, or I'll set the fast acting solenoid just to simulate real life experience. Any questions?
Can you run us through a test procedure of the stop valve, whereas you would actually use the test valve rather than the fast acting solenoid?
Alright, so set them both. Set them both. You said to do the fast acting.
You do the test solenoid down to a certain
Okay.
percentage, and then you would engage the fast acting or normal test procedure.
Or I don't know if I can do, because they're both solenoid, right?
Yeah, you'll just have to go from one to the other. So if you energize the test solenoid, and then as it's coming down, you can go ahead and move forward and then energize the fast acting.
Oh, okay, okay.
After it's
So here's the test solenoid being energized.
you can do your fast acting right after that.
I can't see it, so
That's all right.
and then there's the fast acting.
It's fine. I could have slowed it down. Yeah, it's they give you enough time.
Yeah, in like a real life situation, if they were just doing it just to run the valve, they would use the test solenoid to run it down like 10 or 50%, and get the fast acting to shut it down.
And it would be much slower probably than this all.
What is some reason they might want to test a valve like that? Like, why would they want to move it or close it like that?
The stop valve, because if you don't, the stop valve usually is open. There's really no reason why you would want to modulate it, unlike the governor valve. So whenever it's open all the time, it gets stuck. So you always want to move it from time to time so that it gets stuck. Whenever like a real trip happens, like time. Yeah, inverse the signal, so you can see it from the 0 to 1 to the snap on computer. Using these two transmitters. If we have more time, I can show you how to calibrate it.
For the double acting servo,